This is a Pegasus tutorial about running large-scale workflows on access and NAIRR resources. And this tutorial, it's mostly focusing on high-throughput computing. Pegasus certainly can do HPC workloads, but HGC is where we're really kind of focusing this tutorial. Why are we using Access for it? Well, Pegasus is funded as part of Access. It is a pretty nice environment for this kind of workloads. We have a web-based submit host that we will use for the tutorial. So it's again very nicely set up for this kind of events. Now, you could obviously install Pegasus on your machine. You could do it on your laptop. You can do it on your campus cluster, or wherever you want to do it. But this hosted version here is set up so that you can bring in resources from other places. That means that you could submit your workflow here on this machine, but you could still bring in resources again from, for example, your campus cluster. The tutorial will have a little bit of machine learning and GPUs. That's really just to show capabilities and how to do that on Access. And there will be homework. And what homework means here is that we're not going to get through the whole tutorial. And we have a lot of different sections, but they're all self-guided and they will all be there after this event. So the account that you have, the Access account, and the tutorial locations that we'll be using, they will all stay there for you to come back at any given time and work on that. There's two parts of this tutorial. We are going to be focusing on both how to design workflows, and then secondly, how do you find resources to run those workflows on? And it's also an interactive tutorial, so interrupt me at any given time. You can either use chat, which I can see, or just unmute and ask questions out loud. So there's many different workflows. Obviously, here's a set of them that we have made for with Pegasus in the past. Sometimes when, depending on your field of science, for example, it's very obvious that you need a workflow, right? You have collaborators that use workflows, or you bioinformatics and use pipelines already. And in that case, it's very obvious. But the more common entry path into workflows is what we call the scripting trap, is that you start developing code on your laptop, and at some point you might outgrow that environment. So, and outgrowing here means like either you're out of resources, or that you maybe have collaborators and you need to share your workflow, and you need to move outside that environment. And in that case, we obviously recommend using scientific workflows. The advantages there is that you get a more declarative approach to your computation, and it's easy to come back to reproduce that computation later. You get automation, right? So like you can focus more on the science and less on how the computing actually happens. You get provenance tracking, so that as your workflow is running, the workflow, you will keep details on how that the execution, where it took place, and performance of that. And you get portability, right? You have that recipe now, you have the workflow, you can move that around, you can easily share it with colleagues, you can publish on the computation itself. So it's very, having that as a base for your computation is really important. The specific workflow engine we're talking about here is Pegasus. This is a workflow engine that's been around for quite a while. Up on the left corner here, is you will see a little bit of our stack. So we are the Pegasus Workflow Management System, and the components planner and monitor and preference sits on top of a system called HG Condor, high throughput Condor. And this is basically a job scheduler, but it has some functionality like simple workflows built into it. As we use those features, but we also use the features that allows jobs to flow outside that that Condor pool. So it goes to maybe cloud resources, other pools, HPC clusters, and so on. Also on this slide, you will see a set of some of our users. One is Event Horizon Telescope. It's a very representative example where data is collected in multiple locations and then combined into some computing in a different location. So in that case, Pegasus is doing data management, moving data around, and and you're doing the computation like that. We also see LIGO. LIGO has been a long-term collaborator of the Pegasus project. A lot of the advanced data management features in Pegasus came as feature requests from the LIGO collaboration. So it's been great working with them over the years. And then another example is the Southern California Earthquake Center. The interesting thing about this workflow is that it's a mix of all different types of jobs. So it has some parallel jobs, there's some really big parallel jobs. It has some serial jobs and it has some GPU jobs in there. And all this can, be happening at different locations. So again, data management here is key where we can move data between different parts of the workflow executing at different locations. At the bottom, there's a link here to our application showcase where we have a bunch of other applications that you might find interesting. So some Pegasus key concepts. One is our workflows are DAGs, directed acyclic graphs. And what that means is that we represent our workflows with the tasks being the nodes in the graph and the data dependencies being the edges. The DAG properties means that there are no loops and no conditional branches. However, we can implement those with, for example, unrolling the loop, or we can do conditionals because with some workflows. Another key concept, and we'll see that when we start doing the hands-on section here, is that planning is a really important concept in Pegasus, where we take a workflow, we plan execution to wherever we want to run that computation, and Pegasus then makes like a computational plan for that whole workflow, and that all happens before we even start running jobs. The workflows themselves are defined with code. We're using a Python API to describe the workflows. And it's a pretty simple API. There's a few things that we need to look at. For example, all data is tracked in the workflow. So if you want to use a file in the workflow, you have to explicitly say, hey, there's a file, and then how that file is used as an input and output and input to the different jobs. The jobs are pretty simple. There's a job, we're adding some arguments, and again, I have to be explicit about what files are used as input and output for that job. And then that's then used for a lot of the planning purposes and even inferring kind of dependencies here. If you want to be explicit, you can say add dependency in this case a child and a parent. And this is useful, for example, if you have dependencies that are not file-based, uh, could be like a database call or something like that. And then we have to be explicit. If you do not use the add dependency and you only use files, Pegasus can infer that dependency, right? Like it knows that this output here is used an input as a different place, and then it will, add that edge between those two nodes. In the past, we have been asked why aren't we using a graphical interface here, and people want to maybe draw their workflows in a graphical interface. And in the past, the answer has been for scalability reasons mostly. It's just if you want to make a large workflow, thousands of jobs or even millions of jobs, you just can't draw that in a graphical interface. Um, but looping over data, for example, and tying this into a data find process is really easy to do in code. So it's kind of natural when you get to that scale. However, fact that we're using code for defining workflows has also enabled us to easily integrate with AI-assisted coding tools like Claude. And we're not going to do that today, but I wanted to show an example and kind of let you know that this is pretty easy to do in this setting. And in this case here, we have, just like what you would do before AI-assisted tooling, you have a set of executables, you have some tools, you have some code that you want to run, you have some input data, and you start, designing that workflow, maybe on a whiteboard. You can pass this into your AI tool, and it will easily generate the workflow for you. And when I say easily here, remember that API is pretty basic and it understands DAGs very well. So creating the workflow is actually the easy part here. A more tricky part is down here where we're testing at small scale. This is important even if you don't use an AI tool, but being able to kind of validate your workflow and make sure that it works, not just in the sense of running tools one by one, but actually validate the science, right? And that's what sometimes is difficult to do at a small scale. But it's important because it enables this, refinement loop. And that's again no different from if you're using AI coding or if you're using just, normal coding. You still need to be able to validate and iterate on your code. So that's an important step. Um, if you're interested in that, one of the things we recommend is that you use something called grounding in your prompt. So this is an example prompt for generating a workflow. And the grounding is that middle paragraph here, middle sentence. And really what we're doing is we're just saying, hey, when you generate this workflow, look at this other example and base the new one based on an existing one. And what this does for you is that it gives kind of a scope to the AI, and it gives an example of style and kind of guiding the AI a little bit on what you want the output to look like. And that's hugely helpful here. If you leave this out, AI will probably come up with something, but it might be a little bit more disorganized than you would if you when you ground it like this. So that's what we recommend you do. Now, I said before that planning is a really important step in Pegasus, and here's an example of why it's important and how it kind of works. So on the left, we have what we call an abstract workflow. This is what the code generates. So I can go back to the code just quickly here and I'll show you. Um, if you look at this, the page HTML here, I don't give it a path or anything. I'm just saying there's a file called page HTML. Same thing with curl, same thing with word count. Like I don't say specify paths or anything like that. So this is what abstract means, right? We have an abstract workflow where we don't specify details in the sense of paths. We don't specify the execution environment. We don't specify, where those files are stored. And what this enables us to do is to reuse and replan this workflow for different execution environments at different times. So this is really the recipe. This is really what you can, give to your colleagues or publish on. It's a high-level description of the computation, not where the computation took place. So what Pegasus does, it takes that abstract workflow and it translates it into an executable workflow. And it does that with a bunch of different, for example, graph transforms. In this case, you can see that there was some jobs added. These are mostly data management jobs. So there's some data staging, there's some cleanup jobs. Again, Pegasus can do this because it knows where data is needed and not needed anymore. So it can determine where to put these cleanup jobs because we have this worldview. We know where the whole workflow looks like when we start planning it. And then we have some stage out jobs and so on. An important point here is that this executable workflow might look different at different times you plan it. It could be different because the execution environment is different. An example of this is, let's say that you want to run a workflow on your campus cluster, and you have a shared file system, that means data management, looks a specific way, and Pegasus can figure that out. The next day you want to run this on in Amazon Cloud, and now you're using S3 as a data store, and now you have to do data management against that S3 bucket. And again, Pegasus knows how to do that, but again, the workflow here would look different, right? Like the data management will look different, and maybe cleanup would look different, all this stuff. So that's just one example of the workflow looking different. And it's also important to understand that it's not always adding jobs that we're doing. Like sometimes there are transforms that combine jobs, or there's transforms that maybe delete jobs that are not needed. Maybe you have partial output of that workflow, and we can reduce the workflow by cleaning, removing jobs that are no longer needed. And all the stuff is, Pegasus is has a lot of smarts when it comes to these graph transforms and figuring all this stuff out for you. And we're going to see this in a workflow we're about to run here. So the workflow we're going to run is very simple. It just has two steps to it. There's a hello step and a world step. We have three inputs here. We have an f.in, that's an input file to the workflow. So that would be, hey, I want to do compute on this file. You have an intermediate file. This is something that was produced by hello and consumed by world. And then we have a final output file that we want to keep as an output of the workflow. And we're going to do this in our Access Pegasus system. So what I want you to do is to log in. So did everybody get Access account? Just do that reaction with a thumbs up, please, if you did get an Access account. All right. Perfect. Okay. So you should be able to log into this here. I put it in chat as well. So just open a browser, go to Access Pegasus, and you should first get your login screen. This might look different depending on what university login you have, but you should log in the same way that you log into your Access account. And uh, what you should end up seeing is an interface that looks like this, where it has two buttons. One is Jupyter Notebooks and one local shell access. And if I go too fast, if you get lost, let me know. Let's stop me at that point, and we'll backtrack and get you going. So what I want you to do is start a new notebook. Go to Jupyter Notebook and click that. You can start a new one. The number of hours doesn't really matter. Do 2 or 4 or something like that. Just as long as it's more than one, so that we have time to finish this. And you will click Launch. I have an extra one. I'll delete that. All right, so what we're waiting for here is a little button here. It should just take, less than a minute for this to start up. And it should say connect to Jupyter, and click that. And what you will see now is a file listing. This is really your home directory on this system. And mine has some extra stuff in it. Don't worry about that. What you want to see is Access Pegasus examples. And everybody should have that in their home directory. So click on that. And what you see in here is a set of tutorials. And we're going to do a few of these. These are the ones that are numbered 01 through 09. There's also some other examples down here, the domain examples where you can look at later. And that, for example, if you're in bioinformatics, you can look there and see other examples of bioinformatics workflows that you can, base your new workflow on. But we're going to start with 01 Quick Start. So click on that. And in that directory, you will find a notebook called 01 Quick Start API. Start that notebook by clicking on that. And you will see a Jupyter Notebook opening up for you. These notebooks are designed to be self-guided, so there's a little bit extra text up here, but this is stuff that we already talked about, for example, what the workflow looks like and so on. So what we're going to do, we're going to step through these. So just use the run button on top and do cell by cell. So first run, and we get down to the second cell, which is our first workflow. This workflow is a complete workflow, very basic. Obviously, that's that hello world one that we looked at. This one is set up to run with inputs and executables from our workflow itself. This is, and from our node itself. So everything here is local. And we're also going to run this locally. Like this means that we're not going to try to run this outside the current machine. We're not going to yet run it on an access resource. Um, we're also going to create this f.input file. We're just going to create it with this content, just a couple, like a sentence that says, hey, this is hello world. And then we define the workflow. The definition here, remember, we have to be explicit about all the files. So we have to define f.in, f.inter, and f.out. We have, and then we can define our jobs. So that's here's a load job. We add some arguments. And one thing to note is that we can specify arguments as input files or or output files, doesn't really matter. But we can just specify them directly in here in the command line, or we can do it as a string, right? So this formats the f.inter as a string in here. Pegasus doesn't really care if you care here in arguments if you do references to files or if you do the strings, either one is fine. And then we add inputs and outputs. So this first job has an input of f.in, and then he had an output of f.inter. This is an intermediate file. Remember that that's a file that we might not care about as a final output of this workflow. So, and thus we set stage out equal to false. What this tells Pegasus is that this file can be deleted when we're done with it. So once all the jobs have consumed this file, we don't care about it. We can delete it. Pegasus can delete it. And this is opposed to the final output where we say stage out equal to true, which is the default. And really, so once this workflow is done, what we expect to see, we expect to have f.out, but f.inter is not there anymore. It's been cleaned up. And we do this to make sure that we maintain that footprint on the file system, right? We don't want to take up extra um, space. But it's also really important if you have a big workflow, right? Think about that bioinformatics pipeline where you pass a lot of data between the different tasks. And if everything was an output, you would just end up with this huge directory of stuff that you just didn't care about because all you care about is that f.out. So this is an important management thing that Pegasus does for you. All right, and then we're going to visualize the workflow. So hit run on this one as well. Okay, Pegasus did some stuff. We are going to look at the graph.png, so run this node as well. And you will now see Pegasus re-rendering that workflow back to us and saying, here's what the workflow looks like that you designed. So we have a hello, we have a world, f.in, f.inter, and f.out. This is exactly the same workflow we drew before. It just happened to be vertical instead of horizontally visualized, right? So that looks great. We did a good job in designing the workflow. Let's now run it. So we're going to run in the next cell and this cell here that says workflow plan. So workflow plan, this is again the brain of Pegasus. It goes in and it traces that executable that abstract workflow and it makes it into an executable. And all we tell it is where the input data is with inputters. We tell it where to run it. This is local. Remember, we just told it to not run anywhere except local. We tell it where to find software, where to put output, and to submit this workflow. The submit is all this glob that you're seeing here. what it will say at the end, your workflow has been started and has been given this unique directory. It's a unique run directory for your workflow to run in. And it also says you can monitor this command line tools that Pegasus ships with. So there's some tools called Pegasus Status, Pegasus Remove, and stuff, and they all take this directory as an argument because that's how you interact with that instance of the workflow. However, for us, we already have a handle to the workflow because we're in the notebook in Python. So we can just keep on using that workflow object, and we can run status on it. So we can run that and see what happens. And it will give us, it's again, it looks a little bit like command line output because it is, right? It's the same or output you would do if you would run this on the command line. And what it tells us is where the workflow is running. It tells us about the different work jobs, the state of these different jobs. So mine is 58% done. And we can go down and we can run workflow wait. And what this does is gives us this progress bar. It gives us a progress number and it tells us what the state of the different jobs are. Right. One of the things that's interesting here is look how many jobs that my workflow ran. Right, so it ran 12 jobs. And if we look at what we gave it, we had two tasks, right? We had just had hello and world, and Pegasus decided that to run those two tasks, it needed to add 10 jobs and ended up with 12 jobs to run. And this comes back to, again, this picture up here, right? Where Pegasus were given two jobs in this case, and it ended up being 10 here. You don't worry about the number, right? It's because adding 10 jobs for two sounds like excessive, but that's just in, small cases, those are the number of jobs needed. If you ran like 100 or 1,000 jobs, it would still maybe just add 10. So it doesn't scale linearly on how big your workflow is. That overhead is just a lot now for the demo workflow, but it's not something that would happen, for a real workflow. We can look at the output. So now run 3 and the cat cell, and we'll see that this is the input that we gave the workflow. The first job added some stuff, including where it ran. So that's on the local machine. We never left because we told it to run locally. And then the second job, it also added just the node that it ran on. We can keep going here. We can run 4 and that little code, and what that will do, it will run statistics. So this is the provenance data that I was telling you about, that as the jobs are being executed, all Pegasus collects a bunch of data on the jobs, and some of that is performance data. So we can see overall how many tasks and jobs we ended up, if there was any incomplete or retries. I had none, and that they were all successful, right? Succeeded 12, 2 and 12. My workflow took about 2 minutes to run, and it did 32 seconds of compute. Now, this is obviously, again, not great for a production workflow, um, but for demo workflow, it doesn't matter, right? So what happened, what we want to see is a speed up, right? We want to have some number here, let's say a couple of hours, and a bigger number here was saying, hey, they took 2 hours to run 4 days of compute. So this is again not representative of what you will see in production, but the point is that there's all this data that's being collected for you automatically, and you can also dig even deeper into this where it has CPU information, it has memory information, and all this stuff, performance numbers that you can get from the provenance database. So let's now keep going. So let's step through 5. And what we're going to do here is we're planning the same workflow again. And note that we did not redefine it, right? It's the same abstract workflow. So this is an example of how we can use the abstract workflow over and over again. And all I'm going to do is, instead of running this in on the local machine, I'm going to run it in the Condor pool, which means that this will run on 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 an access site somewhere. So start this, and you will see this one actually has the weight in it, so it will give us the little progress bar. And this will take a few minutes. I might not stay around wait for this to finish, but let me explain what's happening here, right? So because we're saying sites Condor pool, and we can look at this picture here a little bit. What happens is we are here on demand in the Jupyter notebook. We're using the Pegasus API and so on. We're handing that workflow off to Condor to run the jobs, and Condor will then find some remote resource to run this on. This happened to be a GPU node, but it doesn't matter. The point is that there's some node somewhere, and I'm intentionally being vague here because we are going to get to this point and describe where this is happening. But it is a virtual machine that's getting started up for you that will run these jobs for you. We'll see that in all the examples from now on. So my workflow started running. It's going to be the same output, so I'm not going to wait around for that. But what I want you to just leave with here is, hey, I started locally. I ran it the second time remote on a compute resource, and it didn't really take any change to workflow. I just repointed the same workflow to a different location. So you can leave this running and look at that. I'm going to keep on going with slides just for interest of time here. So where were we? Okay. All right. So exactly where that workflow ran is not super important, but the second point here, right? We know how to do a basic workflow, and the Access Pegasus system here, one of the things that allows you to do is to easily add compute resources to that system. And these resources is, resources that you have somehow. It could be that you have an allocation somewhere, Access, NAIRR, OSPool. It could be that you have some commercial cloud credits that you want to use. It could be that you have a campus cluster that you already have access to. And Pegasus is able to use all of those, right? It's a distributed computing system, so we can just add stuff to the system, manage the workflows in Access Pegasus, and bring the resources to us. Um, so most of the time you have those resources. We have something called a test pool, which is a small number of resources running under our allocation that allows you to do the tutorial, that allows you to develop workflows, use Access Pegasus in the classroom, for example, without getting your own allocation. And this will work fine for small, maybe even medium workflows. But if you have something bigger you want to run, then you go out off and get your own allocation. And I'll talk about this again a little bit later here in the tutorial. We talked about this already, how we went from an abstract workflow to an executable workflow. One of the questions here, though, right, is said that this abstract workflow doesn't have information about data locations or software locations or anything like that. So where does Pegasus get that information? How can it go from its abstract to this executable workflow? And what we do is we have something called catalogs that contains that information. So there's a site catalog which describes the execution environment, and that basically could be locations on your cluster or so on. It could be directories. It could be endpoints. Most of the time, this is almost empty. Like if it's just a Condor pool you're running in, you don't need to specify anything else. But if you have a more complex environment, then you will probably add stuff to the site catalog. There's a transformation catalog, which is just a fancy name for software. And in the transformation catalog, you can specify if you have scripts that you want to send with the job, if you have pre-installed software on some execution site, if you have containers, if you want to run the scripts in containers and so on. And we'll see an example of that in a bit here as well. And the last one is a replica catalog. This is the input files that the workflow needs to get started. And it's called replica because you could have more than one location for these files. But most of the time it's just, hey, I have this file that the workflow needs, and here's where you can find it. The neat thing about the replica catalog is that it can be local files, but it could also be remote files. So that means that if you are pulling data from, an external service or a data location, then you can just specify that, and Pegasus will then figure out how to get that data. So you don't have to move the data first. You can just point Pegasus to it, and Pegasus will do the data management for you. So let's do an example of the catalogs. We're going to go back into our notebook. The first notebook is done. I'm going to close that. We're done with that one. So you should still have a tab that has the file browser. And if you find the Access Pegasus examples directory again, we're going to do 02 tutorial data. Right? And this is the same workflow. So we'll start that notebook. And again, if you get lost here and if I go too fast, stop me and I'll let you catch up and help you get going. So what this one does is again the same workflow. The really difference here is we're going to say f.in is not local, it's somewhere else. So we're just going to see what that means. How do we build a catalog and how do we specify the URL for that file? So we'll step through this. We do run, run, and run. This is the same workflow, but note that there's no input directory here anymore. So run, and we get down to the section 2, where we're going to specify input file. And here's the little code where we build a replica catalog. So we're going to have the f.in file again, and we can add some metadata. This is optional. Pegasus adds a bunch of metadata by itself, stuff like dates and size and checksumming and all that stuff. But we can add extra data if we metadata if we want to be able to kind of look at the provenance data later and get some details from this. The most important part is that we have a replica catalog and we add a replica to it. We're saying, hey, this is a remote file, f.in, and here's the location to get this file. So in this case, it's an HTTP URL, but that could be an S3, it could be Globus Online, it can be, WebDAV, wherever you have this file, Pegasus can go and grab it and start a workflow like that. And that's all we have to do. We don't have to tell Pegasus where to put it or anything like that. Pegasus will figure that out as part of their planning process. So step through this, run. It creates a YAML for us. That's how Pegasus handles this internally. Don't worry about it. Um, and then we can define the same workflow again, right? So again, remember, this is the same workflow. We haven't changed anything really. The only thing we've changed is where f.in is coming from. And that step, when I ran that code, it did the whole thing, the plan and the um, the plan and the wait. So it's waiting here now for this workflow to finish. And it should be pretty quick the second time around. The reason this is quicker here is that thing about the test pool starting virtual machines, all that should be done. So this should be a pretty quick step through of the workflow. We don't have to wait for resources to appear. Please give me a thumbs up if you have gotten to this location here where we're waiting for the workflow. Perfect. Perfect. Okay, I think we should wait for this. Let's see, it just takes a minute here. I just want to see if we can look at the output together. Um, Come on, buddy. It's still waiting for me. I don't know it's going. Okay. Yeah, we'll come back to this. Really, the difference here is really going to be the output where it says where this workflow ran, where the jobs ran. Um, but it's not really, the whole point here is really saying it doesn't really matter where the input came from, right? We're still doing the same compute, the same everything. The only difference is Pegasus did some extra data transfers for us. It's about to complete. Now I will wait for it. Uh, the last couple of jobs here is the cleanup and the data staging, so it should be pretty quick. Okay, mine is done, so we can look at the output. And really, the big difference here is where did this run? So the host name here looks a little bit funny, but it says test pool CPU and my last name, a date, and then Nova local. So this is a temporary virtual machine that got started up for me. It's running on IU Jetstream 2, so it's running on an Access resource. And this is a, again, temporary kind of virtual machine. It will stay around for a bit and then it will go away. It's using my allocation, so I'm getting charged for it. And yours here will look different. It should say CPU, but your last name and your timestamp. So it will look a little bit different. But the point is, this workflow ran on an Access resource. So let me do a few more slides and then we'll do another example again. Um, A big part of what the administration at Pegasus does is really monitoring your computation for failures and handling those failures for you. And the way that it does that is with looking at job failures, and this is, the standard exit code, Unix exit code methodology, where non-zero exit code means a failure. There's other ways of doing that in Pegasus, but that's the default. And if the job fails, it will retry a couple of times. You'll be surprised how often that works. There are always a little bit of, maybe intermittent problems in these systems. So retrying the job can make a big deal, a big difference. If something happens where the workflow can't make any more progress, so let's say you're running a big workflow and the machine that you're running on is going down for maintenance for a day, or there's a file system problem or something like that. Pegasus will get to that point and it will say, hey, I can't make any more progress. I'm going to stop here. And when it stops, it writes out what we call a rescue DAG. That means that the full state of that workflow is written down and you can start from that location later. So all the computation that you did up to that point are not lost. You can start over, you can start and pick up from that location and the workflow will just keep going. So nothing is lost. If your application allows checkpointing, so this is common in machine learning, for example, where we have, um, the code will write out state every so often. That's something that Pegasus can pick up and manage for you. And there's also a set of debugging tools. We'll see this a little bit later, where we have a Pegasus Analyzer tool that instead of you looking for that error, looking for a job that failed, Pegasus Analyzer will pinpoint it for you and tell you what the error was. So that's also really helpful when you do debugging your workflows. We talked about provenance already, but some of the locations some of the things that goes into that provenance database. data locations, software versions, parameters used, and execution statistics. So at the end, you basically get this whole proof of where the computation happened, how it performed, and so this is again really can be important when it comes to reproducibility and making sure that that the code ran as you wanted it to. So let's do a more real world example. Let's do a machine learning one. So what we're going to do is close the tutorial notebook. I want to get back to the tab which has the file browser and go to Access Pegasus Examples again. And you will see there's two chapters here, 05 and 06. They both tutorial machine learning, and there's one training and one inference. The training will train a model. It will take about half an hour, so we're not going to do that. We're going to jump directly to the machine learning inference, which will use a model that we've trained already. So it's basically the cooking show thing here where uh, we're pulling the cake out of the oven already. But this is a really interesting example. So start with 06 tutorial ML inference. Make sure it has the inference in there, and then start that notebook. Let me just explain what this does. Actually, what I want you to do, step through as far, like keep on hitting run here. I want you to get all the way down to where we have the weight. So I want to click all the way down till you see the progress bar here starting. And once that's started, I'm going to talk about it. But it takes a minute here to run, so that's why I want you to start this beforehand. All right. So what this workflow does is, or this machine learning model, is that it trains on set of leaves, pictures of leaves, and these leaves could be healthy or they could have some disease or some problem with them. So this is an example here where we have some miscolorization on this leaf. And this model has been trained to take all these and then determine what disease it is, what kind of leaf it is, what we can do about it, right? Like some fixes for the problem. And the other thing that will happen in this workflow here is that I'm going to show you what the input to the workflow looks like, and then we'll talk about it. There we go. So the downloads are all remote, and there are 10 of them. So there's 10 different pictures that we want to run inference on. And so we can pick one here. Number 2, okay, that has a different disease. Number 4, that's a healthy leaf, right? So what we want to do is run the model, one on each one of these jobs. And this is a very typical kind of workflow problem, right? I have a set of files, I have some input data, loop over that input data, and run one job per input. So what we're doing in this full workflow, it's organized a little slightly different. It has a class. This is really kind of just preference, how you want to organize your code. It has some helper functions for planning and status and weight, but these are really just wrappers around the workflow API that we talked about earlier. And then it has a site catalog. We're not going to worry too much about this. It's just really a plain catalog. What we are going to look at is the transformation catalog. So that's line 108. And what this transformation catalog, remember, this is the software that we want to use. And the script that we want to use called classify disease. So this takes the input of that image and the model, and it says run the model with this input and give me the information. And what we can see is that we have this script. It's stageable, which means that we can send it with the job. It can wherever the job lands, it will have this script with it. We also say, hey, but you have to run in a container. And this is very common when it comes to more complex software stacks. In this case, it's PyTorch and a bunch of other AI machine learning stuff. And so that's references this container up here. And this container, we can see it's a singularity container. There's a URL where we can grab that container. This could be a URL, it could be local file system. Again, the Pegasus doesn't really matter. It could be a Docker hub. But we need to be able to get that container somehow to the jobs. We also specify resources here, like number of GPUs. We need a GPU and we need 28 gigs of RAM. So that's what how we describe the software stack for this job to happen. So that's one new thing. The other thing is we're creating the workflow. So I'm on line 156 now. And we see a loop where we're saying, hey, loop over the 10 different images that we know that's an input. This kind of looping is super common, right? This is looping over files. It could be looping over a directory. It could be a data find where you go out and saying, hey, look for data in this part of the sky, and then for each image in that area, do these jobs. But the looping is one of the things that makes this really, really powerful. And in that loop, for each image, we're going to have some input that's a unique image. It's remote, like we said, in a replica catalog. We know we're going to have a prediction file, and that prediction file is based on the image ID. So we're going to have a unique prediction file for each output, for each job. The job itself, classified as Cs. And you can see here, I note that I don't say anything about what script, what container to use or anything. This is just the logic of running this tool with these arguments, with these inputs and outputs. Right. And you can see the inputs here is the model checkpoint and training info. So this is everything that we need to do the inference, and then we have the image file. Now, if we look what this looks like on as an output, as a rendered image of this workflow, you'll see there are the 10 jobs. Each job takes the unique input and has a unique output, and they have common inputs of the trained model. So let's see how this workflow is doing, if it's running yet. Mine is still waiting. So while this is waiting, we are going to just do a few more slides. We are running a little bit low on time. But this basically is going to find a GPU, run the workflow, and then give us this prediction data. So we'll come back to that in a second here. But while that's happening, let's talk a little bit more about resources and where we can run our workflows. So we looked at this picture already, access resources and air resources and so on, but it's pretty high level. So let's talk a little bit about the details behind this picture. What we're using here, and this is really a good solution for high throughput jobs, is the pilot model. We call in Condor world, it's also called a glide-in. But the idea here is that when I want to, target a resource, let's say a campus cluster or a machine in your lab or something like that, you can just go and get this, bring in the resource to Access Pegasus as a pilot job. And this pilot job, what that does is runs other jobs. It runs your compute jobs. So we can reuse this pilot over and over again. And once the workflow is done, that pilot will, self-destruct. It will remove itself, and you won't be charged any more resources. And how this pilot job happens is slightly different in different locations. The test pool we already talked about, that's automatic. You don't have to worry about that, but it will only handle small workflows. For bigger things, you get an allocation. Could be an access allocation or NAIRR allocation. This here describes the 4 different types of access allocation. If you just want to explore allocation, which is still 400,000 hours, that's not a small chunk. All you have to do is write a paragraph or two. It's very easy to get this type of allocation and allow you to kind of bring in those resources. Once you have your allocation, You can choose between cloud and HPC resources. And cloud is what we have used so far today. We provide a virtual machine image that you will start under your account, and that's how you get charged in your allocation for it. All we have to do is basically a copy and paste in a little bit of a token, security token, and start that image, and it will join in and allow to you to run jobs. And this also self-terminates. So again, when the workflow is done, you don't have to you don't get charged for unused resources. If you have HPC resources, you will see here that HGControl Annex is a tool that knows about a bunch of systems in Access and NAIRR. So the Delta cluster, Stampede, Expanse, Anvil, Bridges 2, and it knows about all these different queues. So the neat thing about this being pre-configured is that it's pretty easy to start these pilot jobs. What you do is you type HCon annex create, how many nodes, what lifetime, what project to charge to. So this is your allocation, what GPU type if you need one, and what queue and resource. So that's all. You don't have to specify paths or anything else that on these resources. HGControl Annex knows about them already. The downside with HGControl Annex is that it only knows about these resources. If you want to run somewhere else, you will have to um, use a different tool. And the tool that we provide is called Pegasus Glide-In. This is a tool that you can run anywhere. The example here is Slurm, but you can really run this on a net. Let's say you have a lab machine with GPUs or something like that you want to bring in, or you have your own campus cluster, then you can use the Slurm way here. This is very, very flexible. Anywhere you have resources, you can run this tool, and it will just connect back into Access Pegasus and start consuming your workflow jobs. So before I go here, let's go back and look and see if our crop health finished. It did. At least mine finished. So let's first do statistics on that. It's the same as before. It will just say, more time maybe. Um, but let's look at the output and see what happened. So I'm going to keep on running here. The output, I get 10 files, which is what we wanted with 10 inputs, 10 outputs. Okay, so we have that leaf with, for example, the 0, 0 leaf. And let's look what the predictions looked like for that. So the predictions is a JSON file that specifies that this is a potato leaf and it has late blight in it. And it will give us a little bit of a treatment, what can we do to prevent the fertilizer and so on. And it gives an alert as well. So this is a really neat way of kind of classifying these issues, and it shows that we could run this end to end. So before I leave, I'm going to just finish up of looking forward a few slides here. One of the things that we are doing is we work on the next version of Pegasus. And one of the things that it will include is a little bit of AI augmentation. No surprise that everybody's adding AI to everything. But the way that we're doing this is pretty neat. So one of the tools that we mentioned is Pegasus Analyzer to help you pinpoint issues in your workflow. Here's an example of what Pegasus Analyzer does today. It will show you the standard error, and sometimes these are hard to read, right? This says an expected local file does not exist, and it gives us a pointer. So yeah, I know what the error is, but what can I do about it? So the AI augmentation will try to do a little bit of root cause analysis. It will group your errors in, and it will tell you again, hey, the reason here is that the file didn't exist, but here's what we can do to kind of fix this problem. So this is something you will see, starting summer maybe in the next Pegasus version. Now, if you need help moving forward, We are here to help. We are funded to help you. So don't be shy. We have private email support, Pegasus support at ISI.edu. This email goes only to the developers, so you can ask, kind of private questions on that. We do have mailing lists if you want to do public questions or announce lists to get updates. We have a Slack channel, so you can join our Slack. That's on the same page there. And we run office hours once a week on Fridays at 11 a.m. Pacific time on Zoom. So you can just drop in here, do some screen sharing, and ask questions about your workflows and your computation. So we're happy to help there.